Cha-cha. Perfect. That's great. I feel like you guys should give us an encore, like, and bow. That was great.
More. Again.
Again.
Happy
birthday
to you.
Happy birthday to you.
Let's put it in different language. Yeah, you would know.
Yes. Happy birthday.
Well, you should know that. I don't know the rest.
Okay, cool. Cool. So, happy birthday, Zach. Okay. Sweet. So you notice that I left the stuff from Geometry Fundamentals on the board. It's on the left side. What? Part of the reason is just to like jog your memory. What we're about to do, this is first lesson. You learned half it last year in Geometry Fundamentals, or if you're in Geometry, they covered it. But do not despair, because I will cover it again, and I will act like you remember nothing. So this is perfect. We're going to meet. It's going to be great. All right, so trig functions, here we go. 12.1, we're going to split this over 2 days. I notice I have a review 12.1 day. That's in case this takes 3, whatever. And if it takes 2, we'll literally just go through more problems on the 3rd day. Hey, maybe we'll do a Kahoot. I don't know. Depends if I have enough time to make it. All right, so let's get going. So, just an FYI, because apparently you do not learn this in your other classes. Oops. Does anyone know what this Greek symbol is?
Oh my god.
No.
It means theta. And this is the variable that you put in for your angle. So, if I say, what is the angle here? I could say, okay, theta equals question mark. I don't know what the angle is. So whenever you see theta, it means angle.
Is there a mark for like beta and alpha?
So yeah, you can have more than one angle. Right? So if I look at this room right here, right? Jog back to last year geometry. So I could have one angle right here in the corner. I could have another angle. Put your arm out. Hey, look at the angle between our arms. Hey, so it's the second angle. What about the one right here? There's third angle. So I could label each one of them. I could say, okay, that's that's the angle called alpha, beta, whatever. But in general, we're going to be using theta. So different ways you'll see theta. You might see it like this. You might see it like this. It's a Greek symbol, and that's what they decided to use.
Okay.
All right, I don't know if everyone heard that question.
Oh, that we're in the store now?
No, not at all.
Damn it.
Those are other ways that they didn't use it.
No, so this is my gentle way of reminding you to respectfully open your ears by closing your mouth. It's kind of like a jawstring. Ready? Open your ears, close your mouth. You're going to listen now. It's my nice way of telling you to be quiet and stop talking and be on task. Cool. So he asked, why theta? Why is that the variable? It's just the way it is. Why do we use x all the time for variable? I don't know. They decided that's the way it is. Why is this my left hand and this is my right? Because we decided, everyone was like, okay, we have to be consistent. That's going to be theta. It's a Greek symbol. Yes, Matt?
Why does math rarely...
No, okay, this is not on task. Okay. All right. So let's keep going. So if theta is the measure of acute angle of a right triangle, what does right triangle mean?
There's a 90-degree angle.
Right triangle means there's a 90-degree angle. So this right here will help you with your SAT math. Hey, because there is a little bit of trig on SAT. Cool, same. Okay, so if theta is the measure of an angle, what's acute mean again? Acute? Less than 90 degrees. Then the following trig functions, trigonometric functions involving the opposite side, op, adjacent side, adj, and the hypotenuse, hype, are true.
So what can tell us?
So literally, what we're about to embark on is studying triangles. Trig, tri means 3, so if we're doing trigonometry, we're studying relationships of 3-sided triangles. Except here, we really want right triangles. Right meaning one of the angles is 90 degrees. Do you have a question, Maya?
No.
You're eating food? Okay. So like, let's be snappy about it. Let's not like prolong it.
I'm not getting your food.
Okay. So sine is, we say sin. Cosine, tangent, this stuff you went over in geometry last year. So if I wanted to take sine of an angle, I'm literally doing a ratio. I'm comparing two sides. If I'm doing sine, what are the two sides I'm comparing?
Opposite and hypotenuse.
The opposite and hypotenuse. Okay, so check it out. If this is my angle right here, right? You guys see that little yellow angle? Let's label the sides. Which is my hypotenuse?
Five.
The 5, because it is the longest
Oh,
side.
wait, that's a 4, 5, 3. That's a
Yeah.
special triangle.
It's a special triangle as well. So hypotenuse is the longest side. Here it's 5. All right, what about the opposite side? What's the opposite side from my angle?
4, 3.
It's literally, if you were standing where the angle was, the opposite is what you're looking out upon. So this is going to be my opposite side. My opposite is 4. So if I'm trying to take sine of this angle, what I'm looking for is the ratio between the opposite side and the hypotenuse. If sine is a very small number, guess what? The opposite side is going to be way smaller than the hypotenuse. If sine is a big number, guess what? The opposite side and hypotenuse are going to be very close. They'll be very close in length. So these are just ratios. I'm comparing two side lengths. All right, cosine is the adjacent over hypotenuse. So where is the adjacent side? 3. So the way I remember this is literally, here's your angle right here. Which is the side that helps form part of my angle? As long as it's not the hypotenuse, it's the other one. So this is my adjacent side. Cosine is the ratio. It's how I'm comparing the adjacent side and the hypotenuse. How do they compare? So trig functions, these ratios, sine, cosine, compare the side lengths. Okay, we're okay so far? All right, we're grooving. Tangent is
Opposite over adjacent.
opposite over adjacent. So you're looking at the two short sides. I want you to know, okay, I have the hypotenuse. How do the short sides compare against each other? Are they roughly the same, or is one much longer than the other? All right, and so have you guys heard of reciprocal functions?
Yes.
What is, well, we know what the word reciprocal means. Reciprocal means what? Flipped. So if I do 1 over sine, that's going to be,
Sine over 1.
that would be sine over 1.
So just sine.
So cosecant is the reciprocal of sine.
And what is a cosecant? So,
Cosecant, so instead of taking the opposite over hypotenuse in a fraction, you take the hypotenuse over the opposite side. So it's just looking at the reciprocal of the fraction.
so what is it solved for? The English thing?
You're still solving for the ratio. Okay, so I'll come up with an example. How many guys are in this class?
1.
No, 1, 2, 3, 4, 5. Okay, so right now we have 5 guys. How many girls do we have? 1, 2, 3. No, wait. Did I count wrong? No,
6.
no, 6 guys. I'm sorry.
You forgot Jonah.
No, I forgot Max because he's right here.
Hello.
1, 2, 3, 4, 5, 6. Okay, girls. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's like I'm saying 6 boys to 8 girls. Or I could say 8 girls to 6 boys. So it's the reciprocal.
I know.
Sometimes, so the reason we have the reciprocal function is sometimes it's easier to use that function than the sine one. Because imagine if you were trying to solve for the hypotenuse, get hypotenuse by itself. Well, it's on the bottom of the fraction for sine, but it's on the top for cosecant. Okay, so we'll get more into that. Cosine's reciprocal function is secant. So this is 1 over cosine. That's what's equal. This is 1 over sine. Cotangent is 1 over tangent. Okay, so the example here with this triangle, sine we said was opposite over adjacent. Okay, blah, blah, blah. Let's actually just go through an example that you haven't done yet.
I'm so excited.
Find the 6 trig functions for angle G. Okay, so which one's angle G?
32. No. I don't know.
Angle G is the angle right here.
24.
Angle G is the angle right there. Are we all clear with where we found the angle. So angle G is you look at the point. Oh wait. So when I say angle G, put your finger on G. All right, you put your finger on it and you're like, okay, so that is the angle right there. Angle G is the one where this vertex is. So if that's my angle, let's go ahead and let's label our sides. So where is my hypotenuse?
40.
How do you know it's the 40?
It's
Because it's the longest. It's the biggest one. Okay, what about the adjacent side? Adjacent. 32 is adjacent. And that means if you were standing where the angle was and you're looking out, the opposite side does not even touch the angle. So this is the opposite. Okay, so now that we have these labeled, let's go through and write our 6 trig functions. So first, I want to do sine. So the easy way, so that way you don't forget, like, oh, is sine with opposite, adjacent, like blah, 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 we use SOHCAHTOA. Have you heard of SOHCAHTOA before?
I have.
Yeah. So last year, they did cover this, but I write it a little differently. That way I never forget what's on top and what's on bottom. So for instance, this first one, sine of my angle theta is going to be equal to opposite over hypotenuse. So that's the way I first learned it, and it's like, oh, I never have to forget what's on bottom. Perfect. So sine, S-I-N, that's an operation. If I'm taking sine of an angle, I'm literally doing a math operation on it. It's kind of like if I'm saying, it's kind of like the multiplication or division symbol. Sine is an operation. Sine is an operation. Yeah, except we don't know the angle, so I can't just be like, oh, sine of the angle, because I don't know what the angle is. But what I'm wanting is just the ratios. So here, sine is the opposite over hypotenuse. So the opposite is 24 over hypotenuse 40, but I could simplify that. What goes into 24 and 40? What number? 4, okay, so 24 divided by 4 is 6.
8. I'd say 8 instead. Really?
It's okay, we could have went to 8 or we could have went to 4. It's just like we have to make sure we keep going until it's fully simplified. You could have divided both by 2, and then by 2 again, and then by 2 again. It's okay. Like, all the roads lead to Rome, right? We got the answer, regardless if it took you 1, 2, or 3 steps. Okay, so I have sine. Let's do cosine. Cosine is this middle one, a over h, so adjacent over hypotenuse. So the adjacent side to my angle is 32, and my hypotenuse is 40. What is a common factor between 32 and 40? What number goes into both? 8. Okay, so this is 4 over 5. And lastly, tangent. That's the TOA part. So opposite over adjacent. So this is 24 over 32. And once again, 8 is a common factor of both. So I divide 24 by 8, I get 3. 32 divided by 8 is 4. So I have sine, cosine, and tangent, and now I have to figure out the other 3. Well, the reciprocal functions, I just have to flip the fractions. So cosecant is the reciprocal of sine, so it's just going to be the reciprocal of what the ratio of sine was. So these are like the reciprocal functions. Reciprocals, okay. So the reciprocal of cosine is cosecant. I'm sorry, is secant. Reciprocal of cosine is secant. So so I had cosine was 4/5, meaning secant's not going to be, flip it, 5/4. And then tangent was 3/4, so the reciprocal of cotangent of that same angle will be 4/3. So I have many examples of this, and hopefully we'll get a little quicker at it. Let's try the next one. Do you want to try it yourself first? Let's try it ourselves first. First, let's label the sides, and then let's have you guys go through it. So let's label the sides. Oh my god, look, we already have the angle figured out for us. But, how do I figure out the hypotenuse? Oh, okay, and what do you call this? Pythagorean theorem, and this is my C length. So I need to figure it out. So 24 squared plus 40 squared.
It's 45.
Ooh, even better. Okay, 45 squared. You guys have a calculator?
Yeah, it's 51.
It's 51. So the square root of 24 squared plus 45 squared, because you could actually put that into your calculator and it'll tell you it's 51. Okay, so I have 51 is the hypotenuse length. We can go through, label what each side is. So the longest side, hypotenuse. 24 is my which side, Ethan? Is it my adjacent or opposite?
Which one?
24.
Is your opposite?
Close. Here's the angle, and it's literally part touching the angle.
So it's
Adjacent. Which means 45 is going to be my opposite side. Alright, so I'll give you guys 30 more seconds. Let's write out all of the ratios. Is this what you guys got? So literally you just have to find sine, cosine, tangent, and then you'll just be flipping them for the other three ratios. Okay, so if you're done with B, I believe I put a part C on the next page. Yep, so try those out. Does anyone need more time on this page? All right, so try out C and D, and then we'll go over the answers. So this one, I see the hypotenuse is 11. The opposite side is 5, but I don't know what my adjacent side is. So I have to use Pythagorean theorem. A squared plus B squared equals C squared. So I'm going through and I find, okay, 96 is equal to my adjacent side squared. So if I take square root of 96, that's my side. Can I simplify this radical anymore? I'd like you to keep it in radical form. So let's see, does 4 goes into 96? 4, yeah. So let's see, 4 goes into 96. Let's see, 2, 24, okay, so this is, let's see, square root 4 times square root 24. So right now I'm at 2 root 24. Remember how we went over this before? Simplifying radicals? Wish I could break this down further. 4 and 6. So root 4, root 6. So this is 2 times root 6, also known as 4 root 6. Okay, so now that I have that side length, that's the hardest part. Now, just pound through the ratios. Perfect. And if you already did this problem with decimals, go back because you need to do this with radicals. I need you to have the radical fully simplified. All of your ratios must be fully simplified. cosecant, secant, cotangent. And so all of these three are the reciprocal functions. So that's why when I took sine's value of 5/11, the reciprocal of it will be cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. So that's why once I figured out sine, cosine, and tangent, I could do the other three. Cool. All right, last one. Let's try D. So I have my adjacent side is 3√3. My opposite side is 3. And then I need to find my hypotenuse. Let's see. So 3 squared plus 3√3 squared equals c squared, the hypotenuse. Am I okay to scroll down?
Wait, isn't this a special?
Haha. Yes.
So then you get 3 times 2.
It is going to be a side length of 6. Because what squared is 36? 6. So the way I did that, let me slow down a sec. 3 squared plus 3√3 squared is going to be my hypotenuse squared. So this is a special triangle, I believe, going over in geometry. We're going to hit it again, this unit, this section in particular. Alright, so now that I have those three, all three sides, I can go through and find my ratios. I'm hoping by the fourth example we're good. We know sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So wait, 3/6, I can simplify that to the 1/2. What would cosine here be, Liana?
It would be 6 over
Cosine? Adjacent, 3√3,
3,
which is √3/2. So if I'm simplifying 3 and 6. So, all right, and lastly, tangent, opposite over adjacent. This is 1 over √3, or you can say √3/3. How did I get that? How did I go from 1 over √3 to √3/3? Close. Rationalize it. All right, so I'm rationalizing it, meaning I could go over here, multiply by √3/3, and I'm left with √3/3. Okay, that's how I did that. Go through, use the reciprocal functions. Cosecant will now just be 2. Secant will be 2 over √3. Or you could rationalize it and say 2 √3/3. Yeah. So let's say, let's do 3. Okay. So, do I have room right here? Perfect. Rationalizing it. Okay, so if I have, let's take the secant. So cosine was √3/2. Meaning, when I flip it, secant's going to be 2 over √3. Some teachers are super picky on having a radical in the bottom. So if I want to get rid of the radical, I can multiply by 1. It's a clever form of 1. So I'm going to multiply by √3/3, because then I have 2 times √3 over √3 times √3. What is √3 times √3? 3. Okay. Because this is the same thing as √3 squared. The root and the square cancel out. Okay. Friendly reminder to put your phones away. Get them out of your pocket, put them in your bag. I'm really sick and tired of telling you guys to do this, and then you continually bring them out. All right, example 2. if tangent of A is equal to 5/3. So sometimes your book, the problems I assign, the SAT, ACT, they won't use theta. Sometimes they'll put in a different variable. But most of the time they do use theta. That is like the standard to go. That is what they use most times. All right, so if tangent of my angle is 5/3, find the values of the 5 remaining trig functions. Okay, so pause. What? SOHCAHTOA, tangent of an angle is what? Tangent of an angle is TOA. Opposite over adjacent. So that means that, oh my god, this means 5 is my opposite side and 3 is my adjacent side. Can I draw a triangle with this? Yep, 100% I can. So I'm going to draw a triangle. Let's label this A right here. So here's my angle. And let's fill this out. So I know that I only can use tangent, cosine, sine on right triangles. So I know I'm going to have a 90-degree angle. And then I'll just label one of the other sides theta. So going from that one angle, the adjacent side we said was 3. So the side that's closest to the angle will be 3. And the side opposite of my angle, so that's one right here, is 5. Okay, so we just did a problem similar to this. Yep.
3 squared plus 5 squared equals c squared.
Beautiful. 3 squared plus 5 squared equals c squared. Well, but it's not, because the hypotenuse is not 5. We're needing to find the hypotenuse.
It's 34.
9 plus 25 equals c squared.
So it's radical 34.
Right, so the side length is rad 34. Can I simplify this radical anymore?
No.
Well, how do I simplify it? I don't want the decimal. I want like, 2 root whatever.
No, I think this is as simple as it gets.
Yeah, because let's see, what are the factors? 1 and 34, 2 and 17. There's no perfect squares as a factor. So that's it. I just leave it that way. Okay, so first thing we did, constructed a triangle. So I want to review the method of how we approach this. Construct the triangle. Then, now we have all the side lengths we need. I have the hypotenuse. I have the adjacent side. I have the opposite side. Follow SOHCAHTOA, fill out your ratios. So sine of, well, I should really put A, I'm sorry. Let's stick with what the problem says. Sine of A is opposite over hypotenuse. Opposite, 5, over hypotenuse, root 34. If I wanted to rationalize this, how would I do that? Rationalize. Multiply by root 34 over root 34. So then I see sine is 5 root 34 over 34. So next year, if you're taking trig and advanced algebra, you probably will have to rationalize it. But for me, I don't know. This is probably because, I wasn't I am the math teacher from the time I was 5. No, I was oh, I love math. I should teach it, right? Let's make it fun. For me, I don't care if you rationalize. I just want you to have the right answer. I just want you to get to the last step. I want to know, can you figure out which side your opposite and your hypotenuse and then put it in? Cool. Sometimes it's better if you don't rationalize. Sometimes it is not, whatever. Yeah. So that's why either one of these I would be chill with. Next year, totally just make sure you ask your teacher what they prefer. No, you'll find out in June. So cosine of A, so let's continue. Cosine is adjacent over hypotenuse, so 3 over root 34, or you could say 3 root 34 over 34. Tangent, opposite over adjacent. Oh my god, they already told us it's 5/3. Surprise. I just wrote it anyway because I'm trying to find the 5 remaining trig functions, and as we've been doing so far, I find sine, cosine, tangent, and then flip them. Find the reciprocals for my reciprocal functions. So sine, let's see, 1 over sine A is cosecant. I don't know why I'm writing that. This is on your paper, whatever. Cosecant of A is going to be, well, the issue is, if I had rationalized this, if I had rationalized it, I have to go over here, flip it, oh my gosh, okay, I flipped, blah, blah, blah. Okay, why don't I just go back to what I first wrote, flip that, and then it already has the radical in the numerator, the top of my fraction. So this is root 34 over 5. Secant, root 34 over 3. Cotangent, 3 over 5. Awesome. So I want you guys to try the next one. Huh? Yes, I want you to try B. So I think Algebra 2 spends, no, 1 day on this, and we're spending 2. So. If B, let's see, tangent B equals 2, what is cosine B? So wait, I'm not actually looking for all 5, I'm only looking for 1.
Adjacent is 1.
Yep, so I'm going to write it out just like this, 2 over 1. Tangent is TOA, opposite over adjacent.
Wait, how do you decide what angle that you're looking for?
So I'm not actually looking for an angle here.
No, but when you decide the opposite.
So they gave us tangent of some angle equals 2. And I know tangent is opposite over adjacent. So meaning, if tangent of some angle is 2, that means the opposite's 2 and the adjacent's 1.
I know, I get that. But like if I draw the triangle, like we draw a triangle like that. And then like, yeah, so like which angle do you decide? Oh, I'm going to make the opposite from this.
So there's 3 angles. As long as you don't pick the 90 degree one, you should be fine. So if I could actually, I put it up here. Like, check it out. Here's my angle B. As long as I label them consistently. So versus, I'll draw both. That way you guys can see the difference. Okay. So opposite is 2. So opposite from this angle is here. Versus if I was on the right triangle, the opposite is here. This is going to give us the same answer. Adjacent is 1. Adjacent's 1. Right, because 1 squared plus 2 squared equals hypotenuse squared. 1 plus 4 equals hypotenuse squared. That's how we found the hypotenuse. So if I'm wanting cosine, cosine is SOHCAHTOA. SOHCAHTOA. Cosine is? Adjacent over hypotenuse. So on this left side, the adjacent side is 1. Hypotenuse is square root 5. How would I rationalize this? So I multiply by rad 5 over rad 5.
We can just keep it like that, right?
Yeah. So rad 5 over 5. Let's check on this other side. Let's see. Cosine adjacent over hypotenuse. No, I'm sorry. Oh god, that's not hypotenuse. Hypotenuse. So that's, oh, it gives me the same thing.
Do we have to draw a triangle?
Yes. You must draw the triangles. Because there's points for that. It's really, well, I mean, it's easy for me to grade if you get something wrong because you didn't set it up correctly. The more you show me your thought process, the easier it is to give you as many points as possible. Because if I can identify at what point you went off track, sweet, I know exactly how many points to give you. If I'm like, well, you only wrote the answer, well, shoot, you're wrong. You mix it up. Can't help you there. Okay, that's it. We only had to find cosine. Let's do part C. If tangent of A, okay, I'm sorry, let me pause. Is it clear that like you could pick either angle, but we still get the same answer in the end? The key is, if I had this be my angle, I had to make sure the one opposite was 2. And if I had this as my angle, I'd make sure the opposite one was 2. Like, it's just being consistent with how we labeled it here. Okay, do we see that it gives me the same answer?
Yeah.
I drew 2 triangles. I picked either angle I could. As long as I'm consistent with which one was the opposite side and which one was my adjacent, you will get the same answer. All right. If tangent of A equals 11/17, what is sine of A? All right, so I'm going to have you guys try this. I'll give you about 30 more seconds or so, and then we'll go over it. Yes. Sure. Well, first I'll try and calculate see if it's a actual number. It's not. I've gotten this. Let's see. 2 doesn't go to it, right? Maybe like 2 and 20-ish. 3 doesn't go 4.
No,
Is it literally it's split?
no, but you can break down 5.
Well, you can pull it out.
Because
it's not.
So it's just round the same. So we just keep it round.
Yeah, that's what you have to do. It is, yeah, it is 410. Yeah. Okay, cool. All right. Oops, I forgot to push pause. Whatever. All right. Are you guys done with this one already? Yep, try D. So I can't break down 410 anymore. So we're running sine. Sine is opposite over hypotenuse. Let's see, opposite 11 over hypotenuse, square root 410. Cool, that's it. Do we have questions on this one? Let me have you soak it down a little bit. And if you are done, she'll go on to the next one. Like, I want you guys actively engaged trying these problems and trying to have it more like, I show you, you try. I show you, you try. That way when you're on the test, you'll know what to do. You won't come up to me and be like, am I on the right track? No, I'm done with that life, right? Let's really try to engage our synapses. Yeah, good question.
Are the equations going to be on the test, or do you have to
Like
the?
I mean, you should know, Sokotoa. Let me think about it tonight. Let me think about it and I'll let you know.
Just like the.
I'm gonna ask to see what Algebra 2 does, because I don't want to make it harder than Algebra 2. If Algebra 2 gives them the equations, then I definitely will give you them. But if they don't, then I'll think about it. Yep.
Is there like a homework packet we're getting?
Yeah, there is a homework for this, but I'm not giving it out till the end of class because I don't want you working on it in class. All right, so try the next one. If sine of b equals blah blah blah, what is cosine? Okay, so I know Sokotoa. So this is my hypotenuse. This is my opposite side. So here's the angle I'm interested in. Opposite's 8, hypotenuse 15.
What time is class on?
25, so you have 5 more minutes, and we're going to use all 5. 15 squared equals 8 squared plus, I don't know, let's just call it b squared. 225 equals 64 plus b squared. Is this what you got so far?
Yeah.
Perfecto. All right, 225 minus 64.
161.
161. Does anything go into 161? No. Okay, so it's just going to be root 161. So if I'm wanting cosine, Sokotoa. Cosine b is adjacent, root 161, over hypotenuse 15. Okay. All right, let's pause here. How are we feeling? Yeah, got this?
Like it, except for having to remember these.
Yeah, I mean, you're going to be using them, so the idea is, like, you'll know them. You won't have to, like, memorize because you'll know it by using it. So reciprocal identities, We've done stuff already like this. It's useful to know various trig identities. The following are reciprocal. Cosecant is 1 over sine, secant's 1 over cosine, cotangent's 1 over tangent. Rad. So, for example, if sine of angle B is 1/4, find the values of the remaining 5 trig functions. So it's exactly what we were just doing. Okay, so it's exactly what we were just doing. So let's finish with this problem. This is a good stopping point. So let's do this one. So sine is opposite over hypotenuse. So I draw my triangle, have my 90-degree. Here's my angle I'm interested in. My opposite side's 1, my hypotenuse is 4. So using Pythagorean identity, I have 1 squared plus b squared equals 4 squared. So I see b squared is equal to 15, so that means this other side length is root 15. Because you take square root. You can't simplify. That's it. There's no perfect squares as a factor. So if sine of b is 1/4, let's hit the easiest one first. What would the reciprocal function be? Cosecant of b, which is just 4. Right, so 2 down, 4 more to go. Cosecant, 4 over 1, which is just 4. Cosecant is adjacent over hypotenuse. Root 15 over 4. And when I flip it, secant will be, secant of angle B will be 4 over root 15. If I rationalize it, I get 4 times root 15, all over 15. All right, 4 down, 2 more to go. Tangent of B. Opposite over adjacent. Opposite over adjacent. 1 over root 15. How would I rationalize this? Root 15 over 15. And that means cotangent of that angle is just going to be root 15. Yeah. So that's it. This is a good stopping point, and we'll pick up tomorrow.